So now let's take a look at how Combine fits in with your application architecture. Combine can play a role in many areas of your application, including networking, service objects, your domain model and application state, any kind of system event handling, and the UI. Each of these areas may lean on different parts of Combine, but ultimately, we're dealing with publishers, operators, and subscribers. So when dealing with external services, external APIs, I often wrap these sort of behaviors inside of what I call an API client. Some people will call these services, but regardless of what you call it, the sort of fundamental concept is the same. You want to wrap up any kind of networking logic for making authenticated requests against an API, sort of interpreting the results into models that you control, and either saving them or delivering them to your application. Now, typically with Swift, you would have a completion callback that maybe uses Swift result type to give you either a value or an error, and it might look something like this. Now with Combine, it's good that not much changes. Instead of taking in a completion callback that then is called later with a result type, we instead return an any publisher of the type that we expect or the type of error that might happen. And it's actually pretty easy to translate these because we're just returning a publisher and we don't need to worry about maintaining the subscription because that's the responsibility of the caller. So we saw in Module 4 how we can take advantage of writing our own custom operators to simplify and unify our logic to make it more reusable, more readable, and so we can create networking methods that return publishers that look like this. So the main point to drive home here is that all we're doing is returning a publisher, and it's up to the client to manage that. And because we're returning a publisher, the client can determine what queue the response gets called back on, or it can combine this work with other publishers to make sure that work is done in parallel or in series as needed. And we have a single place to handle errors, following through the error handling that we did in Module 3. So one huge benefit to this approach is no matter how the client wants to consume this, we're not going to have to be nesting completion callbacks for all kinds of asynchronous and synchronous steps in our flow and ending up with kind of completion callback hell. So next, let's talk about the UI layer. I think Combine really shines in this area of your application because this is where all of your domain logic and your application state and functionality sort of gets distilled into something that we display to the user. And UIs typically have to sort of coordinate many asynchronous events in order to show the correct state on the screen. The specifics of how Combine is going to look in your UI is going to depend a lot on which UI framework you're using, either UIKit, AppKit, or SwiftUI. But one fundamental aspect of Combine will remain the same, and that is that we typically set up our behavior ahead of time and then just let it play out and interpret the events as your application is running. So in a UIKit scenario, most of this code might get set up in a view-did-load, for instance. This isn't necessarily bad, but it can lead to kind of a lengthy view-did-load method, and you'll have to think a little bit differently about how you want to break this apart and extract new concepts. One concept that we've already seen is the ability to sort of factor out our pipeline into different publishers that make more sense. Like for instance, we used formatted email address, which was a computed publisher that did a lot of the work for us and gave us an abstract concept that we could work with in our view-did-load. Combine doesn't ship with deep interaction with UIKit controls. As a result, you're going to have to write this code yourself. And as we've seen, we often use subjects as a way to bridge the gap between the target action event handlers that we have with UIKit controls and pushing those values through a Combine pipeline. So as you've seen, subjects help us bridge into the Combine world, and you'll often see them used at the seams like this. So in UIKit, if we factored out all of these different publishers and we're setting everything up in view-did-load, it can actually add quite a bit of non-trivial code to your view controller. And it does beg the question, does this code actually belong here? I'd argue that this code is fairly specific and probably deserves a new home. The one approach we have is to factor out this code into a view model and use the view model to sort of maintain all of these publishers and the state of the view, and then our view controller can just subscribe to that and be a little bit dumber, which makes it a little bit easier to write and easier to test. So while this course is not about SwiftUI, I do want to talk briefly about how Combine fits in with SwiftUI apps. So Combine and SwiftUI go hand in hand. They're both declarative frameworks. Swift UI's views are lightweight and they're meant to be recreated as the underlying data it is based on changes. So when the state changes, the Swift UI view re-renders. Now, if we leverage observable object and the publish property wrapper, anytime a publisher publishes a new value, that can indicate to Swift UI that it needs to re-render this view. So here's an example. Here we have a counter with two methods for mutating the value. Since we're leveraging the publish property wrapper, we get the publisher the combined behavior for free, so anytime this value changes, it's going to publish that change. Next, we can create a Swift UI view that uses this. Here we're using the @observedObject property wrapper, which will basically observe the object for us, and whenever it indicates that it changed, it will tell the view to re-render. Because the publisher and the observed object go hand in hand, anytime a publisher changes, it will tell Swift UI to re-render that view. So while we didn't use combine directly at all in this example, it is being used under the hood to facilitate this workflow. Sometimes you do have a specific combine publisher, and you can use that in Swift UI too, with the onReceive helper. Here we're using Notification Center's built-in publishers to react to any time a new notification comes in. When working with Swift UI views, you want to be aware that Swift UI views are a struct, and they're meant to be thrown away and recreated as state changes. This means we don't want to be tracking any of our any-cancellables inside the Swift UI view itself. Instead, we're going to put that inside of observable objects, where it can live across multiple view refreshes. So both Swift UI and UIKit apps benefit from extracting some of this logic and putting it into view models. So we're going to look at that in the next section. Okay, so let's talk about view models. Now, view models is kind of an overloaded term, but the basis that I'm going to go with starts with Martin Fowler's definition of a presentation model. So the core of the presentation model concept is to represent the state and behavior of the application independent of the GUI controls used in the user interface. Martin Fowler sort of coined this idea a long time ago, and it sort of morphed a few times, and the typical term that we use today is view models. One application of this pattern is MVVM. So in iOS terms, we often have view controllers here that talk to models. MVVM proposes to insert the view model in between the view controller and the model. So the view controller talks to the view model talks to the model. This gives us a new home that we can place behavior and logic that is related to the UI and presentation of our application, but not necessarily changing our model or our core business rules. This also gives us an isolated place to test some of this complicated UI logic without having to instantiate view controllers in our tests or rely on cumbersome UI testing tools. So imagine we have a model like this. We've got a user that has a few properties on it, and we want to show this user on the UI. So we can start by creating a class for a view model that takes in its user and keeps it private. Now you might ask, why are we using a class for this? We could easily use a struct, but I want to take advantage of the publish property wrapper later on, and that requires the owning type to be a class. Next, we can define computed properties to do things like formatting and display, where in this case we have a first and a last name, and we can use person name components to automatically format this in the way that's most appropriate for the locale. Similarly, we can take the date joined date and use a date formatter to show a friendly user formatted date in the UI. And then similar to that, we can use number formatter with a style of currency accounting to show the user's balance. Now, all of these things are slightly disconnected from the underlying value, but they're formatted for display, and a view model is a great place to put that code. The best part is our view controller gets pretty simple. The only real interesting code we have is this. Create a view model, pass it in the user, and then use all the properties just like you would if it were a model. Next, let's talk about modeling UI state. So imagine we have this make payment button, and this should only be enabled if the user's balance is negative. So we'll start by updating our model. The canMakePayments property is a Boolean computed property that checks to see if the balance is negative. Then we can update our view model to contain something that's UI specific about making the payments button enabled. Notice that we've split apart the actual business rule from the UI state rules. It can sometimes be tempting to put the business rules in the view models because that's where we're using them, but the underlying fundamental business rules should be contained in the model. Then in our view controller, we can just use the view models property to set the button state to hidden. Okay, now let's talk about making it reactive. So far, all of this code has just been standard UIKit code, and it's not going to do anything to react to any changes in that state. For instance, if the user's balance then changes from negative to positive or positive to negative, we need to know to reevaluate that code to change the state of the button. So this is where combine really fits in. Instead of using a plain property for our user, we're going to use a private published property. This is going to give us the benefit of having a free publisher anytime our user changes. And we also have a function here that can update the user that we can call to mutate the state. Now we can transform the properties that we were using earlier into publishers. So here we take $user, our publisher for our user. Anytime that changes, we're going to map that user into its formatted name. So this is the same code that we wrote in our computed property from earlier, but we've just wrapped it in a publisher. And now we're just exposing a publisher for the UI to consume. We can do the exact same thing for the date joined and the balance properties. These now return publishers that we can bind straight to our labels on screen. And of course, now the Make Payments button visible can now react to the user changing, can check to see if the user can make payments, and if so, it'll return true or false whether or not that button should be visible. So with all of these publishers, we've now added the ability for our view controller to react to these changes. And we can use the assign subscriber to assign these directly to our UI controls. So it might look like this. Inside of our view to load, we're going to either create or maybe reference a view model that we have already. And then we're going to start binding these to our events. So here we've got our name. I'm going to map that to the optional string so we can assign it to the text property of our label and store it in a cancelable set. And we can do the same thing for date joined and for the balance. Finally, we can do this for the Make Payment button visible, and we're done. So as you can see, view models are a really useful pattern for extracting some of this logic out of the view controller and giving it a new home, and giving us a nice place to put all this formatting logic and code that we can use to drive the UI. And an added benefit is this becomes a lot easier to test because we can just create an instance of our view model and start interacting with it directly as a state-driven test rather than a UI-driven test. So now that we've seen how view models can be applied to our applications, let's go back to our sign-up form example and we'll refactor it to use view models instead. Okay, so we've got our sign-up example and I want to refactor this to use view models. So if we take a look at this, we've got some subjects that we use to send values through to combine. We've got some cancelables that we're using to keep track of our subscriptions. Now we set everything up inside of view to load, which uses a whole bunch of computed publishers to sort of massage and transform the data into things that we want to work with. And then we have all of these kind of helper computed publishers down here. And these are really the prime candidates for refactoring and putting into a view model. So what I'd like to do now is add a new file here called signup view model. And let's just open up our view controller and sign up view model side by side. Now inside of here, we can import combine. And the only time I would import UIKit in here is if I wanted to use something like UI image, but I want to try to not import UIKit. So I'm not tempted to put any kind of UI controls in this view model. So here I'm going to create a class for sign up view model. And then over in the view controller, we can then create an instance of that. So I'll do private var view model equals sign up view model. Now all of these subjects can actually be moved to the view model. So I'm going to do that. I'm going to bring those over here, and so that they can be used externally, we're going to make them not private. So now everywhere we're using those, we can say view model.email subject, etc. So I'll just copy and paste that, and we'll have to do those here, but I also want to move all of these helpers over into the view model as well. So I'm going to bring those over. Some of these are going to be used over here on the view controller, so not all of them need to be private. In fact, the whole point is for you to be able to use these if you need to. So I'm going to make all of these not private. We also need the isValid email address rule to be contained in the view model. And you could argue that this maybe belongs somewhere else if you have some sort of model that the purpose is to validate email addresses. But this will work for now. Okay, so our view model looks good. We have a whole bunch of errors here. So what I need to do now is add view model dot in front of all of these subjects so we can send values into them. And then as well, all of these different publishers that we are using are all going to come from the view model. Okay, so let's build, make sure we have no compile errors. And let's take a look at what we have. We've got our UI view controller has its controls. It's got a view model and it's got its subscriptions that we'll still need to keep here. And it's still got all of its setup, but all of the values are coming from the sign up view model over here. And so we've actually reduced this code by about half. Before we started with about 140 lines of code, and we've moved about 70 lines of that code over to the view model. And this is a pretty good win. It clearly shows that we have some code that kind of can easily be separated from the view controller. The other thing about this is it would be easy for us to just create an instance of this and start setting properties and sending values through this and testing that the publishers work the way we want. And we can do all of that without having to instantiate a UI table view controller and, having all these outlets hooked up to something that might be configured in the storyboard. And all of those things kind of make the view controllers a little bit harder to test, but we don't have any of those burdens when we try to interact with sign up view model. So I think this is a good first step, but we can go farther. Each one of these things is a subject that we use to send a value through to combine. But we could also make this a published property. And so if I have a published property called email and I assign it to an empty string, that is essentially equivalent to this current value subject. It can retain a value right now, but we could also subscribe to it. So if I say email here, I can change where I'm using email subject to use $email. You can scroll down to where we're using it here, use $email, and that was definitely an improvement. So then down over here where we're using viewModel.email subject, instead of using email subject like this, we're just going to assign a property. And this is kind of reminiscent of code we would write even if we're not using combine. We're setting the email property of our view model to whatever is coming from the text field. Now, if anything is dependent on this, this publisher will trigger a change, like this formatted email address, and everything will still work the way it did before, but we don't have to send a value through a current value subject. We can just use this published property. Let's do the same thing for the rest of these properties. We'll make the password be just a normal property that is a string, and we'll also make password confirmation a string, and our agree terms will just be a Boolean, which is false. So let's clean up the errors we have in here. We can use $agree terms there. This is now password. We can use $password and $password confirmation. This is $password. And we're good on this side. Now over here, we're going to have to change where we're using these. And we'll just set the password subject equal to this. We'll do the same thing for the password confirmation. And the agree terms switch. Now we're still using that over here. And see, this is where we needed the aspect that we were using a current value subject was definitely a requirement so that we can read the value. But we can also just check the value right here. Okay, let's give it a quick build and make sure we're building. Okay, so again, I've just kind of simplified the interface to use published property wrappers instead of current value subjects. Okay, now looking over here, we still have a bit of logic that's happening. And what I would like to do is start extracting some more of this into the view model. For instance, I think we could have some publishers for some UI state here and have the notion that we have some of our fields that need to change their text color. So here we could create an email field text color property and make that a UI color. Now this is another one of those cases where we'll have to import UIKit, but I think, color is more or less a model object, so I think that's fine. So now we've got a publisher for this text color. Let's do the same thing for the password field text color and the password confirmation field text color. Now we are going to have our view model set up these subscriptions. So I'm going to create an init method, and I'm going to call a method called setup pipeline, which I'll define right here. Now we're going to sort of separate our behavior here. So I can say configure email address behavior, and we can separate that into its own function. Configure email address behavior. And so here, what I want to do two things. I want to format the email address, and I also want to set the text color to red when invalid. So here we've got a formatted email address already, and what I can do here is call remove duplicates on it, and this will automatically filter out things so that we can avoid setting the property back to the text field again. And then what I want to do is assign this. And what I'm using here is the assign to publisher. What we can see here is assign to with the ampersand allows me to assign this directly to a published property wrappers publisher. So here I can use $email. So what I've done is anytime email changes, we format it. That triggers this pipeline here, which removes any duplicates. So if we've already formatted, we don't need to do it again, and assign that to the email property. So this is the same as this rule here. And now we don't really need this rule as it stands right here. What we can do is just say, I want to take $email, map it to an optional string, and assign it. So we've kind of moved that formatting rule over to the view model. The other thing to point out here is that because we're using this assigned to a published property wrapper, the memory for this subscription, the maintenance, is held by this published property wrapper itself, which then is owned by signup view model. So we actually have no subscription to maintain. It's sort of maintained internally for us. Next, let's work on this next requirement. We can say check to see if the email address is valid. And then we can essentially map this to some color. And I'm going to write the code that I wish that I had, map to input color. So we've got a Boolean, and I want to map this to a color. So let's write an extension on publisher where the output type is Boolean and the failure type is never. Now we can run that map to, what did I call it? Field input color. Let's go check. Map to field input color. Let's make that. And what is this going to return? Well, this is going to return an any publisher with the output type of UI color. And I want to bind this directly to a label or a text field. So I'm going to make it optional so it'll match, and then never because it can't fail. And then here I'm just going to delegate this to map, check to see if we're valid. We're going to be returning an optional color. And then here I can say if we're valid, then I want to return a label color. And if we're not valid, I want to return system red. So again, this is just syntax sugar here. So now I need to call erase to any publisher on that. And now we've got this kind of helper publisher, which is going to make this code a lot easier to read because I can now say map to field input color. And now I can assign this to the publisher that we're using for that, which is email field text color. And again, I don't need to maintain the subscription because we're using this particular assigned to that takes the published property wrappers publisher. Okay, so now back over here, let's go to where we are setting the color.
we don't need to do this anymore. So I'll delete this one. And now I'm going to say viewModel.email field text color. And we're going to assign that to, and this time I need the other one. So assign this to the text color property on our email address field and store that in cancellables. So these are subtle changes, but we're kind of moving the logic to the right, which I think is the benefit that we're making here is we're kind of removing the logic from the view controller and we're making it dumber. We're just going to say whatever the view model says my text color is going to be, that's the text color. Okay, let's do the same thing for the password behavior. So here I'm going to create private func, configure password behavior. We'll make sure and call it from here. And here we can check to see if we have a valid password. So that's a publisher. We can map this to the field input color, the helper that we just wrote, and assign this to our publisher $password field text color. And we're going to do essentially the same thing. This is going to be confirmation matches, or password matches confirmation. And then we're going to again map that to field input color. So again, you can see how we're reusing this sort of operator that we made to make this a lot easier to read and write. Okay, and this needs to be password confirmation field text color. So we've done that. We need to subscribe to that over here. So let's change both of these. ViewModel.$password field text color. We're going to basically be doing this 3 times. So I'm just going to copy that. This is going to be text color on the password field. And then again for the password confirmation field text color on the password confirmation field. And then lastly, let's add in a property here for whether or not that is enabled, the whole form. So I can say sign up button enabled, and this is going to be initially false. And so now this is going to be configure sign up button behavior. And I like to sort of organize these into separate methods. Here it's, the logic's pretty straightforward, but it does group things up together so that you can kind of focus on what you're working on. And view models can get more complex, and so you want to make sure that you have kind of a nice tidy organization. So for this one, configure sign up button behavior. And this is really just going to check that form is valid and map this value directly, or assign this value directly to our sign up button enabled. But if we had, more things to check, we could just insert it into this chain if we needed to. So now we can bind to the sign up button enabled publisher, which again is just kind of, it's more geared towards the UI state. We can move that to the bottom rather than interpreting the value of the form is valid property. Okay, so now what we can see here is that each one of these properties now is essentially just assigning a value from the view model, and all of the logic is happening here in the view model. Okay, let's run this and just give it a quick test and make sure we're still working. So I can add that, and you can see the text colors are still working, and I can add, my password and agree to the terms, and the sign up button enables, and if I turn any of these things off, the sign up button is disabled. And as you can see, we haven't changed any behavior. We've just refactored this to extract this sign up view model concept out of our view controller, and this is going to give us all those benefits that we've talked about. Okay, let's see how this works with SwiftUI. So I'm going to build a SwiftUI app that we can see on the right here, and this is going to fetch all of the issues that are on the Swift repository on GitHub, and it's going to show them in a list here. And as you can see, we can see the issue title, the author's avatar and name, and the comment count. And so this is what we're going to build, and we're going to focus mostly on the combined specific side of things. If we take a look over here, I've separated this into 2 different targets. So we've got a framework target for GitHub Kit, and that's where I put sort of reusable code that has nothing to do with SwiftUI. So I dragged in our combined HTTP helpers. I've created a few models here for issue and user that we can use to decode the content from GitHub's API. And then we have a GitHub API type here that right now is empty, just has a JSON decoder that converts the kind of Swift naming style from the snake case style that GitHub uses. So the first thing I want to do here is write a fetch method. We're going to make this public func fetch. And I want to fetch sort of any arbitrary endpoint and decode it into the type that I want. So here we can pass in a generic argument saying I want to fetch some model that is decodable. And then we'll have an endpoint here that is going to be a string. And then we will say decoding and then use a model.self here, or rather model.type here. And the reason I like to do this is so that the generic arguments are specified as arguments, and it makes it much easier to write. And we'll see that as we go flip over to the other side of this, which will be consuming this. Now this is going to be return an any publisher, and the type is going to be whatever model type we want or HTTP error. Okay, so most of this should now be pretty much review. We need to get a URL, so I'm just going to build one right now. I'll just hard code the base URL here as api.github.com, and then we will append on the endpoint, and we're just going to assume that that's valid. Next, I need to return URL session. We'll just use the shared session for this example and use a data task publisher for that URL. And now we can sort of do what we've already done before, assume HTTP, grab the response data, call decoding, and pass in model.self, and then use the decoder from above. We want networking to happen on a background thread, but we want to update the UI on the main thread. And when you're dealing with networking, this is going to be a common pattern. Data Task Publisher is already going to do its work on the background thread, and it's going to continue to call each operator on that thread. So if we want to influence and ensure that we are on the main queue by the time we're done, which is a common practice when writing API clients and other things, you often want to do the work and then call back onto the main queue so that you don't sort of give this burden onto the caller. And in Combine, that's actually really easy to do. We can say receive on and say dispatch queue.main. So what's cool about this is that not only the networking, but also all of our processing and decoding is going to happen on a background queue. And then we're just guaranteed that we're going to receive the downstream subscription on dispatch queue.main. And now I can erase to any publisher. So now I'm free to use this inside of the UI, use it to update the UI, and I don't need to worry about it. So that's the generic fetch method that we need to do. And then now I want to go over to our issues list, which is going to show this list of issues. Now I want to do that networking right here, but I don't want to do it inside of a Swift UI view. So instead, we're going to use this issues view model to do it. So I need a reference to that view model, which is going to be issues view model. And I can build one like this. And because I'm inside of a struct and I want to watch this as it changes, I'm going to make this an observed object. And so when I declare this issues view model, I need to make sure it's an observable object so that it can be used like this. Now, anytime this observable object changes, my Swift UI view knows it needs to re-render. And you can trigger that. So let's just say I have some code. I can actually call will change, or object will change, and that will trigger a change. But also if we use any published properties like this, so I'm going to use issues to get back a list of issues. And we can initialize that to an empty array. But now that means anytime I set this to a new value, this publisher will emit a new change, which will tell the observable object that it changed. And now issues list knows it needs to re-render. Okay, let's go back over to our view model here. And over here in the view model, we'll have an initializer, and I want to just call fetch right away. So I'm just going to call fetch, but I also want the ability to refetch at will and let the view decide when to do that. So inside of here, we're going to use that API, and we're going to start calling the method we wrote. I need to do a build so that'll show up. Now we've got api.fetch, and here for the endpoint, I want to use repos Apple Swift issues. And this is the structure that GitHub uses in their API to pull out the issues for a given repo. And now for the decoding, I want an array of issue. So make sure that .self comes after the brackets here. Okay, so what I'd like to do is assign this to this published property wrapper. Now, in order for me to do this, I need to make sure that there are no errors. So I can replace errors with an empty array, and then I can assign that to our $issues publisher. Okay, so now let's go back over to our issues list, And now I can say that I want this issues list to go here. I'm going to put that in a private var issues list, which will be some view. And inside of here, we can say list and grab viewModel.issues. Issues are already identifiable, so the array of issues are identifiable, and I can just use them like this. And I'll get one in, and now I want to create an issue row and pass in that issue. So let's go ahead and build this, and I'm going to run it. So as you can see, it sort of is blank for a minute, and then it pops in, and we can see our issues. So the first thing I want to do is figure out some sort of loading indicator. So I want to know whether or not the view model is loading or not. And if so, I can either show the issues list or show a progress indicator. So I can say if viewModel.isLoading, and that doesn't exist yet, but I'm just going to write it like it does. And if it's not loading, we can show the issues list. So if it is loading, what do we want to do? Let's just put a progress view with a progress view style of circular progress view style. And now I need to define that in issues view model. Let's define a published property for isLoading and initially false. Now, as we've seen before, we want to be able to set this as a side effect of what's happening on this subscription. And so we can use handle events for that. So I'll put each one on its own line. So when I receive a subscription, that's when I'm starting to load. So I can set isLoading to true here. Now, receive output and receive completion in this case are going to be essentially the same, but I also want to do it in the case of failure. So I'm going to delete this and just have receive completion. Self.isLoading equals false. And then I also need cancel to turn isLoading off also. And then we don't care about this last one. So this will give us that loading indicator status. And just to simulate a longer delay, we're going to add a delay for seconds 2 on dispatch queue.main. Okay, so we'll simulate this delay so that we can see this happening a little bit longer. And we see the loading indicator, and as soon as that changes, it knows to re-render the view and show us the issues list. So next I want to handle some errors because it is possible for these to happen, and right now I'm just ignoring them all. So what I'd like to be able to do is take advantage. Let's go back over to issues list. Over here on the group, I can add an alert, and there's 2 different ways to do this. One of them takes a binding for some object that is identifiable, and it'll pass that into this block, and I need to return an alert. Now this is the one I want to show, and so that means I need some sort of identifiable object. So what I'm going to do here is just define a type up here called identifiable error. It's going to take some E, that is an error, and itself be identifiable. Then we'll create some UUID, and then we'll have an error, which is a type of E. Now, so I'm just wrapping it here, so when I assign an error, it's just going to treat it like it's a unique error. Okay. Next, I can have a publisher for that, and I'm going to have an error, which is going to be an identifiable error of type HTTP error, but be optional. Okay, so when I fetch, I'm going to take any error that I had before and set it to nil. Down here in the replace error, instead of doing that, we want to catch that error. And recall that inside of here, I'm going to get at the error, but I need to return a publisher. So I'm going to return the same type of publisher here, but just with a just. So this is going to be just an array of issues so that I can return an empty array there. But now I can take that error and wrap it in an identifiable error like this. And return this. So now we have the same downstream result. It's still going to get an empty array of issues down here, but we've also set an error. So now over here on our issues list, now I can use this alert and pass in a binding to that, which means $viewModel.error. Now it's important to do $viewModel.error like this, which will give us a binding. If we use $error, this is going to give us a publisher, and that's not what we want. We want a binding to that value. Now inside of this, I need to get at the error, which I'm just going to call E. And now we need to return an alert. And here I'll just say text. We'll just say error for now. Okay, so build succeeded. Let's just force this to fail. So here, I'm just going to say try map. I'm going to ignore the upstream value. And here we're going to, actually we can force an error just by futzing that URL. So now we should get a 404. And if I run this, now we get an error and I click OK and it dismisses the alert. So what I'd like to be able to do is retry this if we get an error. So let's change this. We want this to be able to say unable to load issues. So that's the title. Then we'll also have a message, and the message will come from our error. And we've added descriptions for the errors so that we can see what's going on. And then I want to be able to have a primary button, which is going to say retry. So this will be text retry. And then inside of there, it'll have an action of viewModel.fetch. So this is why I wanted that viewModel to have a specific method that we could call fetch on. And then we'll have a secondary button, which is just cancel. Okay, so now we can see unable to load issues. We received HTTP 404. If I hit retry, it'll start loading again. All of our state is kept in sync because we're just binding to whatever state the viewModel says it's in. Okay, so now that we have errors working, let's turn off the invalid URL so we actually get real issues. Now, at this point, we have a working example that shows a list of issues. Now I want to show the author information in there. Now, the author information right now is coming from the issue row and is just reading the issue's title directly from the issue. But we also have things like the author's login and the comments count, and we have the avatar. And I want all of those things to be kind of managed in a place. So we're going to create this issue row model. Now, I've already created it here, but the things to point out here is that I have the issue is set up like this, and we can even make it private so that others can't interact with it directly. Then I expose those properties that we need specifically from the issue. Now, what's cool about this is that I can just say that I have an author property, but that actually comes from some nested, navigation. And so this decouples us from the actual structure of GitHub's response and gives us a cleaner interface to work with in our view. And additionally, we can rename things that, comments sounds like an array of comments, but in GitHub's response, this is actually an integer, so we can rename it to comment count. What I like about this is that now I can have a published property wrapper for the avatar image, and we can determine when we want to fetch the avatar. So I'm going to say fetch avatar. And at this point, now we just need to load the avatar for that image. But before I do this, I want to look at how do we get these issue row models delivered to the view. What I'd like to do is have this passed in. So issue row model being passed in, I'm just going to call it issue. So the idea is that, we're treating it like a model, but it is actually an issue row model. Doing that means that this is going to fail. And I'd actually like to handle that in the issues view model itself. Instead of exposing the model objects directly, I can expose the row models directly. So basically, I've got a view model that exposes other view models. So what that means is I can't assign it directly anymore. I have to transform it. So when I want to transform the content, I'm going to say map. And you might be tempted to say that I want to map that into issue row model $0. But recall that map on combine is slightly different than map on the standard library. What we're dealing with, the value coming down from this, is an array, not a single issue. So if I want to do it this way, I have to take in the entire array, like that, and then call issues.map inside of this block, like this. So this is combines map, which operates on the publisher, the upstream publisher. And this is the standard library map that's operating only on one array. Now, there's one other kind of trick I want to show that I think is sometimes kind of handy and can kind of clean this up, because this sort of nested map thing doesn't read very well, and it's also confusing that this map is different than this map. So one other way we could do this is flat map. So recall that upstream, I'm getting an array, and flat map requires me to return a publisher. So I can use $0.publisher to turn this array into a publisher. Now I can call map, which is going to, again, this is combines map, but it's now operating on each item coming out from this publisher. So now I can say issue row model $0. Now downstream, we're getting values of type issue row model, but this is expecting an array. So what I really want to do is wait until they're all done and collect them all up into an array. And that's what the collect operator does. It will wait for the completion event and then return all of the values it received as an array. So this is, functionally the same exact thing that we did a second ago with the nested maps, but this one allows you to sort of unwrap. So, okay, I've got an array of items coming down. Let me just expand that out and treat them one at a time in here. And then when they're all done, I'll collect them and emit a single array of all those results downstream. Okay, so now our issue row is only going to see issue row models. So now what it allows us to do, this is going to be the issue title, and then we're going to have an HStack for the author information. So here I'm going to have an avatar, which I'm going to make as a separate private var avatar, which will be some view. Here for now, let's return a circle filled with color.gray. And then I just want to make this frame the width 36 and height 36, just so that we have something going on. Okay, so I've got the avatar. Now I want a text with the author, and the font for this will be subheadline. And then I want a text for the issue.comment count. But instead of text, let's use a label. Inside of here, we want this guy to be a string wrapped like this. And then we can use a system image of text.bubble, I think it is, to get a SF symbol for that image. Okay, so let's run this and make sure that we have a circle and the author information. And we do. So now what I want to do, let's add a quick spacer here to push the comment count label off to the right. Now let's talk about loading in these images. Now, I don't want to do it like I did before. I don't want to call fetch avatar here. That's going to fetch all of them up front. And I really just want to wait until you see it showing up in the UI. As you scroll, it should fetch the next ones. So here, we've got a group, and I can check to see if we have an avatar, which is going to come from issue.avatar image. So if we have an avatar image, I want to use it. So we can use an image with that UI image, avatar. Here we want to make it resizable, clip shape of circle, so it shows up as a circle, and then aspect ratio to fill the circle that we've made. Okay, so if we don't have one, then we're going to show this gray circle here, and on appear of this gray circle, we can say, okay, now I want to go fetch. So I can say issue.fetchAvatar. So this will only happen once. It'll fetch the avatar. Then once the avatar shows up, it will change the issue, which we are now observing because this needs to be an observed object, var issue, because this issue row model now is going to change. And now, because of that, it will re-render this row and show the image this time. Okay, so now we just need to define that fetch avatar function. So this one is going to be similar to what we've seen already. Here we'll take URL session.shared, data task publisher for issue.user.avatar URL. We'll do our same assume HTTP and then response data. This time I need to take that response data, instead of decoding it, we want to make it an UI image. And typically you want to work with UI images on the main queue. So I'm going to do my receive on dispatch queue dot main right here before I map that data to a UI image. Okay, so it's possible that this could error out. We could get a 404 or some kind of issue. And at this point, I just want to replace that error with some other image. And we have a default avatar defined right up here. So that replace error, and then I can assign this to our publisher for avatar image. Now let's give this a run. And what we'll see is that the API is pretty fast, so it's kind of hard to actually see the request being made, but we could add our little delay in here. Delay for 1 second, dispatch queue.main. And running it again, now we see, it waits a little bit longer. All of these things are now in my cache, so they're going to be a little bit faster. But this does show that things are working, and it waits until you actually scroll to it to actually fetch that image. Okay, so I'm going to comment out this delay, and we'll do the same thing in our delay right here because API is actually a lot faster. And so this kind of shows our completed example that has our issues with the avatar information fetched. And this is using the view model concept. And this shows the nested view model concept, which allows us to abstract the content for rows and allows us to do some asynchronous work there as well. Oftentimes when working on real applications, you'll have one screen that is displaying some data and another screen that is editing or adding to that data. So in this example, I'm going to avoid talking about any UI, but just talk about the central concept of sharing changes between screens. So here I have a class for a to-do that's got an ID, so we can keep this kind of uniquely identifiable, and it's got a text property and a completed. So what I would typically do for this, if I wanted to have some sort of screen, let's say like the today screen, and this screen is going to essentially just show us all the to-dos. So what I want to be able to do is have a list of to-dos that this can reference and also be notified anytime it changes so it can refresh its display. So to do that, I'm going to create a class called TodoStore. And I like using this sort of suffix as a store. This is where we're storing the related data elements. And that could mean that we're storing it in user defaults or storing it as a JSON file on disk or storing it in core data or wherever it comes from. This is kind of the interface that I would use for the rest of the application. Now here, we could have a private set var to-dos, which is an array of to-do. And we'll initialize that as an empty array. And then here in my init, this might be where I load from disk or database, etc. So this way we could have some persistence. So the reason I make it private set is so that somebody can't come along and just replace this wholesale with a new one, that they have to use these methods like, for instance, adding a to-do like this, and then maybe also removing a to-do like this. Now, the reason I like doing this then rather than letting the array be mutated directly is this gives us flexibility to add some behaviors here as needed. So for now, I'll just say todos.append with that to-do. And then for here, I need to first grab the index of that in the array. So we can say first index of that to-do. If we don't have it, then we don't have it in the array. And then here I can say todos.remove at that index. So now I have a class that I can use, and let's create an instance of that, TodoStore. And I want to be able to pass that into this screen or whatever component we're using. So this will have a store, TodoStore, and we'll take it as an argument to our constructor, and I can save it. So now I want to be able to call this function print to-dos anytime these to-dos change. So I'll say maybe print store.todos. So the first approach that we might use is use published. And this is easy enough. We can see that anytime we mutate the to-dos by appending or removing, it's going to essentially emit an event and show our to-dos here. So in our today component or screen, we might create some cancellables, which would be a set of any cancelable. And then here in our initializer, I can say store.$todos.sync. And here maybe I don't care about the value, so I'll just call print to-dos like this. And I'm going to have to use unowned self here because we're going to be storing this on self. So we'll store that in our cancelable set. And at this point, now I can say that we've got a today screen that we want to hang on to. And then we also want to be able to add to-dos. So I'll create a new to-do, and this will be record a video. And then lastly, we need to pass in the store here in the initializer. So if we run this, now we will see an empty array and then another empty array. So let's sort of figure out what's going on here. So this array, the first array, is emitted immediately. When you subscribe to a published property like this, it will emit the value immediately. And that may or may not be what you want. If it is, in this case, I think I do want to show the empty array. But what happened here? We added a new to-do, and that to-do mutated this array, which triggered a published event on this value. But what we did was we ignored the value sent, and instead we used the backing property. So this is an important gotcha when working with Combine, and especially observable objects and the published property wrapper. The event for this published property wrapper's publisher will be emitted before the underlying property is changed. So the value that comes along with this event is correct, but the backing property hasn't been set yet. And so this can lead to subtle differences. You might wonder why this happens. And this is primarily to optimize the flow for SwiftUI, because the system can coalesce all the updates because they're all firing on object will change, not on object did change. So what we need to do here to fix this particular problem, we could say that we want to pass in the to-dos as a value like this. We'll print out that value. Now we can capture the value in the block here and pass it in here. So if we've done this, then we've just fixed the problem. Now it's printing out that to-do. If we make this custom string convertible, then it'll use our description method here to show that to-do. So let's run it again, and we should be able to see this to-do. And I'm going to bump up the font size just a tad so it's a little easier to read. So now I've got record a video, and it's not completed. So far this works. And what I need to now do is maybe we add another to-do. And this one is, go to the doctor. If we run this, now we get another change event that has all of the changes in it. And if I want to, I can then essentially say that I want to complete that to-do. So maybe I say let to-do equals a to-do of buy some milk. And then we'll add that to our store. And now I want to set the completed property of this to true. So if we run this, we see buy some milk, but we never get the event that it was completed. Now, the reason why we don't get that is because we're only observing the changes to this array. We're not observing any changes that happen inside the array. And so for this reason, you may want to design your data elements to always funnel their changes through a central store like this so that they can be broadcast in a controlled manner. So here we might want to have a function that says complete to do. Now, if we do this, we could set the completed flag to true, but again, this isn't going to trigger the change on this array. So how can we get around this? So one option to consider is that published is maybe inappropriate for this particular use because I also want to be in control of when I say this thing has changed. So for that, I might decide that I want to inherit from observable object. So by inheriting from observable object, not only can I use this in a SwiftUI context and get sort of automatic behavior for refreshing UI views, but if you want to use this outside of SwiftUI, you can as well, because this exposes a object will change publisher that you can subscribe to. And I can send values through this because it's a subject with a void data type, and I can tell it when it changes. So here on my to-dos array, I can say if in the will set, if I want to, I can say object will change .send, but I can also change this to a did set to change that behavior. So now it will only fire after the array has been updated, not before. So this might be appropriate for our use case. In addition, I can go down here to where we completed the to-do and also set this or send this event, object will change. So now I no longer have this $todos publisher So instead, we're going to observe the object will change publisher, and we're going to call sync on that instead. Now this one doesn't pass in the to-dos, and so for that, we can just use store.todos like this. So now we're observing any change on the store, not just the published property wrapper. So now if we run this, you can see that we got the latest change for that last item, but we never were updated because we're just mutating this outside of the store. Now, what this means is we're going to have to funnel our mutations to happen inside the store so we can be in control of when we say something is completed. Now, that may lead you to design your data elements to be immutable rather than allowing them to be mutated outside of the store. In this case, I'm going to have to mutate it at some point anyway, so I'm going to leave it like this. But if you decide to use an immutable structure, like a struct, and make these lets, then the work you would have to do would be to replace the value in the array with a new value that has a completed flag. But in this case, it's a little bit easier for me to just mutate it here and then indicate that it was mutated all inside the same encapsulated method. So now when we run this, we get another change event that tells us that this to-do has been updated, which allows any interested party to react to that. So with an approach like this, you can have multiple screens all working on the same set of data and keep them all in sync by using combined publishers.